Okay. Our next topic is homeostasis. These are mechanisms that the body uses to maintain a reasonably constant environment. It's not, you know, like it's on railroad tracks. But it's within its particular lane, as it were. So we don't get too far out of temperature or um, water balance, electrolytes, those types of things. And we've got some mechanisms that actually push us toward activities rather than keep us within this narrow range. So again, I'm going to go to a presentation. So let's talk about homeostasis, or introduction to that concept of homeostasis. So let's talk about homeostasis. Homeostasis is the maintenance of a relatively stable internal environment. It is a dynamic state of equilibrium. Dynamic means that we are constantly adjusting. Well, we stand up, and though we're unaware of it, we are constantly adjusting muscle tensions in various places to keep us from falling over. Homeostasis is necessary for normal body functioning and to sustain life. Now, we can get homeostatic imbalances when things stop working properly and we no longer maintain that balance, and a disturbance in homeostasis can result in a disease. For instance, we are unable to maintain the O2 saturations properly in our bloodstream. Um, that could be a product of emphysema, but our body sort of adapts, but we are in a disease state at that point. Now, basically, we have just a few things that come into play. We have a variable, which is a thing that we're measuring. So we have some sort of receptor that can pick up a variable. We can't control it if we can't measure it. So we have receptors that pick up internal temperatures, receptors that pick up external temperatures, things like that. The receptor will detect a change, which produces a stimulus, or a change produces a stimulus, which gets picked up by the receptor. And then that receptor, if the change is big enough, sends a signal to the control center, usually our spinal cord or our brain. And the brain processes that information, decides if there's something that needs to be done or not. And if there is, it sends another signal out to an effector, which is a thing that changes the environment, generally putting it back into balance. Now, an example of this could be temperature. Well, I've got the thermostat in my house set for 72 degrees. If it drops down to 69, what's going to happen is that the thermostat is going to pick up that change in temperature, and then it's got a little motherboard inside of it that is going to be the control center. So we've got the receptor built in there. It sends something to the control center, which decides it's too hot or too cold, and that control center will send a signal. In the case of a lower temperature, send it to the furnace at my house, which will kick on, increase the temperature, and as the temperature increases, that gets back into balance. And once it gets close enough into balance, the receptor picks up that change, sends a signal to the control center, which tells it to stop, which causes the effector to shut down. Sort of a quick idea here. Body communicates through neural and hormonal control systems. Again, the receptor responds to a change in the environment, the stimuli, sends information to the control center. Control center determines whether it's within the appropriate range or not, analyzes the information, and determines the appropriate response. Now, this is actually kind of important because the control center can change the set point. That's why we develop a fever when we are sick. Now, we get chemicals in our bloodstream that the hypothalamus picks up on, and it says you have an infection, so we are going to make you hotter. And that process of increasing the temperature is actually to help kill off whatever it is that has infected you. So we have receptor, control center, and effector. And you should know what all three of these are and what they do. Okay? Now, for the most part, we have negative feedback systems. What I was telling you about a minute ago in terms of maintaining the temperature in my house, that's a negative feedback. What it does is when it gets out of balance, our body does something to shut down that stimulus and move it back to its original state. So return the measured variable back. Say a thermostat is set at 75. It'll turn the air conditioning on at 77. It'll turn the heat on at 73. The overall effect is to maintain a temperature of around 75. Different example of negative feedback. See, I like to sing. I'm not very good at it. So what I lack in quality, I make up for in volume. And when I start doing this, and I've done it a little too long, my wife comes back over and smacks me in the back of the head. That's a negative feedback because once I have been smacked in the head, I stop singing. Now, positive feedback, on the other hand, that's a little different. We actually increase the original stimulus to push the variable further. So in the case of blood clotting or childbirth, and I like childbirth as the best example. So if I were to ask you, what is an example of positive feedback? The answer is going to be childbirth. Basically, what happens is you've got a great big baby, and it, gets bigger and bigger, and it eventually rotates in position and starts pressing on the birth canal, and that causes some stretch. And stretch receptors send a signal to the hypothalamus, which causes the release of a hormone, oxytocin, which causes muscle contractions in the uterus. And those contractions push the baby a little bit further down, which causes a new wave of oxytocin to be released and a new wave of contractions. And this continues until the baby squirts out. And once the baby has been delivered, there's no more stimulus, there's no more stretch. So everything slowly reverts back to normal. Another example, I go to Baskin Robbins, and they've got those little pink spoons that they'll give you a sample of ice cream with. So I get one of those little pink spoons, and I find a taste that I really, really like. So I go ahead and order a scoop. That's a positive feedback. And afterwards, I may get that every time I go because I like it so much. So basically, there are a few things that I need to know that you got. What does homeostasis mean? What are the defining functions of life, which we talked about before? What are the survival needs of humans? What are the components of a feedback system? What happens in a negative feedback system versus a positive feedback? And what are examples of positive feedback? Now, I should tell you that practically everything else in our body works on a negative feedback, with the exception of clotting and childbirth. For the most part, everything is functioning negative feedback. So that should take care of the first two presentations, and I think that everything else after that is going to be just fine in terms of having links that go to YouTube presentations. So this may not be quite as polished as I would like, just because I'm kind of rushing to get it out there for you. But hopefully this covers everything that you will need. And take care.